Welcome to my presentation of Android operating system structure. I am Mohammad Mehdi Hassan from CC Department ULab. Let's know something about Android. Android is a modified Linux kernel-based operating system which is designed primarily for smartphones and tablet computers. Currently, it is running on 75% of mobile devices of 2.5 billion. It is increasingly used as the embedded operating system for dedicated devices. Android introduces only a few new concepts to the Linux kernel itself, using most of the Linux facilities. A large amount of the Android operating system and the Android application API are written in Java programming language. Besides, the kernel and a large number of low-level libraries are written in C and C++. Android Incorporated was founded in California in October 2003. Google acquired Android in July 2005, then provided the necessary resources and cloud service support to continue Android development as a complete product. Now we will see design goals of Android operating system. Providing a complete open source platform for mobile devices. Strongly support proprietary third-party applications with a robust and stable API. Allow all third-party applications, including those from Google, to compete on level playing field. Providing an application security model in which users don't have to deeply trust third-party applications. Supporting typical mobile user-Apple interactions, spending short amount of time in many apps. Managing applications process for users, simplifying the user experience around applications so that users don't have to worry about closing applications when done with them. Creating a full general purpose operating system. Now we will see Android system architecture. In the architecture stack, above of the hardware there is Linux kernel, followed by hardware abstraction layer. Native C, C++ libraries and Android runtime are above of HAL. Then comes Java API framework and lastly system application. Let's explore the stack one by one. Firstly, Linux kernel. The foundation of the Android platform is the powerful Linux kernel. The kernel is the heart of the operating system that manages input and output requests from the software. This provides a level of abstraction between the device hardware and it contains all the essential hardware drivers like camera, keypad, display, etc. Android runtime relies on the Linux kernel for underlying functionalities such as threading and low-level memory management. Also, the kernel handles all the things that Linux is really good at, such as networking and a vast array of device drivers which take the pain out of interfacing to peripheral hardware. Using a Linux kernel allows Android to take advantage of key security features and allow device manufacturers to develop hardware drivers for a well-known kernel. The features of Linux kernel are security, memory management, process management, network stack, driver module. Then comes hardware abstraction layer. The hardware abstraction layer provides standard interfaces that expose device hardware capabilities to the higher level Java API framework. It consists of multiple library modules, each of which implements an interface for a specific type of hardware component, such as the camera or Bluetooth modules. When a framework API makes a call to access device hardware, the Android system loads the library modules for that hardware component. Next is Android runtime. It is one of the most important parts of Android. It contains components like core libraries and the Dalvik Virtual Machine (DVM). Mainly, it provides the base for the application framework and powers our application with the help of the core libraries. Like Java Virtual Machine, Dalvik Virtual Machine is a register-based virtual machine and specially designed and optimized for Android to ensure that a device can run multiple instances efficiently. It enables every Android application to run in its own process with its own instance of the DVM. It depends on the layer Linux kernel for threading and low-level memory management. The core libraries enables us to implement Android applications using standard Java or Kotlin programming languages. Next upper part of the stack is platform libraries. The platform libraries includes various C++ core libraries and Java-based libraries such as Media, Graphics, Surface Manager, OpenGL, WebKit, Secure Sockets Layer, SQLite, etc. to provide support for Android development. Among them, Media Library provides support to play and record an audio and video formats. Surface Manager responsible for managing access to the display subsystem. WebKit is an open source web browser that provides all the functionality to display web content. Next part is Java API Framework. The entire feature set of the Android operating system is available to us through APIs written in Java language. These APIs form the building blocks you need to create Android apps by simplifying the reuse of core, modular system components and services, which includes the following: view system, content providers, managers. There are many types of managers such as resource manager, notification manager, activity manager, package manager, location manager, telephony manager, window manager, etc. View system. A rich and extensible view system we can use to build an app's user interface, including lists, breaks, text boxes, buttons, and even an embeddable web browser. Content providers. Content providers can help an application manage access to data stored by itself, stored by other apps, and provide a way to share data with other apps. They encapsulate the data and provide mechanisms for defining the data security. Content providers are the standard interface that connects data in one process with code running in another process. Most importantly, we can configure a content provider to allow other applications to securely access and modify our app data as illustrated in the figure. Activity Manager. An activity manager that manages the life cycle of apps and provides a common navigation backstage. Activities are one of the fundamental building blocks of apps on the Android platform. They serve as the entry point for a user interaction with an app and are also central to how a user navigates within an app with the back button or between the apps with the recent button. Skillfully managing activities allow us to ensure that, for example, orientation changes take place smoothly without disrupting the user experience. User data is not lost during activity transitions. The system kills process when it's appropriate to do so. Resource Manager. A resource manager provides access to non-code resources such as localized strings, graphics, and layout files. Notification Manager. A notification manager that enables all apps to display custom alerts in the status bar. Telephony Manager manages all voice calls. We use Telephone Manager if we want to access voice calls in our application. Location Manager finds out our location using GPS or cell tower. Finally comes the topmost layer of Android stack, application layer. An average user of the Android device would mostly interact with this layer for basic functions such as making phone calls, accessing the web browser, etc. The layer further down are accessed mostly by developers, programmers, and the like. Several standard applications come installed with every device, such as SMS client app, dialer, web browser, contact manager. That's all about Android operating system structure. Thank you for watching my video.